like to welcome you all to the Bolshoi piano competition. We're in downtown Moscow today. I hope you're at the right site, okay? Actually, that's a joke. I was just teasing you a little bit. We're going to talk about EZGUIDE. I'm the founder behind this project, so stay with me and I'll show you what you really tuned in for. What EZGUIDE is about is coming up with a better answer for guide rails and guide rail brackets. Two things we want out of this new design is A, no rods, safety hazard, and B, we want a guide rail system that can change radius in the curves as we change product sizes. Okay, so two objectives here. Get rid of the rods, make smooth curve transitions whenever we need them, okay? So I'm going to show you right now how this works. This is a demo conveyor that we built for you. I'll show you what the idea is here. EZGUIDE is a complete guide rail system. You have the rail and you have adjustable brackets. We also have a rail here and fixed brackets. So adjustable on one side, fixed on the other. The idea behind this is that most of the lines that we deal with have a fixed reference side. All the way through the line, one side will be fixed, all the machines and conveyors. The other side will be adjustable. So that's how this thing is configured. But both these products are EZGUIDE products, okay? Now I'm going to show you how this works. These are what are called manually adjustable brackets. You set these by hand. I'm going to release them all now. Okay, watch what happens here. Seth, can you get up here for me a little bit? Get up on the, I need a kind of a bigger shot here. Here we go. So y'all be patient with us. We're working through it. All right, ready? Okay, now watch this rail right here. See that? Let me do it again. All right, now I've got them all the way out. I come back and I lock them like this. Some of them kind of move by themselves. That's EZGUIDE. If you'll notice, you have a changing radius curve here. I actually changed the radius of this curve as this rail came in. The rail's plenty strong. Stayed right with me. I'll do it again for you. I'm going to release them all. No tools. All the way back. You just start here in the middle, lock them back down. All right, they're all locked back now. See, change radius, see here. Nice, consistent radius through the curve. I'm going to unlock it and do it for you again. All the way out, all the way back. Now, let's say I want to make it a certain distance all the way out. All right, I'm going to set them to a certain distance now. All right, and I'll show you a little later how I was able to do this. Get back down to where I can see pretty good. There and there, and there and there. I've set a certain distance all the way through here. Again, curve stays right here with me. Okay. Let's do this one. I'm going to show you what I'm doing here. This is a manual lock right here. Just pull these locks down. You can move the bracket, lock it back in place. right here. I'm going to do a little bit more discussion about this on an individual basis here shortly, but that's the idea, right? It's called EZGUIDE. Has two advantages. There are no rods sticking out, and I can get consistent curves when I go through them without a whole bunch of work. You just saw that, did it for you twice. Okay, so fixed side, adjustable side. You can have adjustable on both sides if you want, up to you. So that's the fundamentals of EZGUIDE. Now I'll show you a little bit more about it here. Let me add bracket right there, Mike. Here we go. This is what you're looking at right here. This is an EZGUIDE bracket. It comes just like this. It's all assembled, ready to go. Bolts on a conveyor, standard pattern. Fits anybody's conveyor. Belt conveyor, modular plastic chain, whatever you want to do. So we call this a T bracket. Here's how the T bracket works. These are called sliders. Sliders go together, lock them back down. There you go. Very, very simple. Now, the way I was getting to a certain position was we have a set of scales molded into the back here. Probably hard to see on video, but there's a set of metric numbers and a set of US numbers molded in. So you just pick a point, line it up, and then set them. So very simple, clean as we could make it, elegant, inexpensive, right? Now out here, this is where the guide rail attaches. There are two slots here for two guide rails. The guide rail itself that you're seeing here is made out of hard anodized aluminum. That's why it's black. And I don't know if you know much about hard anodized aluminum, but it's a tremendous wear surface. It's very tough. We've had a lot of success with it. We built sprockets for spirals out of it in a real demanding high torque situation. Sprockets have held up well. These will hold up extremely well. But again, there are two slots here. The reason why there's two slots is, let's go over to this curve here, Seth. Because we have what's called a transition piece here. And this is where the two slide together to change the length of this curve. As this curve comes in, the curve gets shorter. This rail will extend. Move it out, this rail will retract. So this is your transition piece. And that's why there are two slots in here. There's a little gap in there as well. So that's how that works. So basically what happens is we start here in the center of the curve, put a set of brackets on that way, put a set of brackets on that way, and let it go. That's about all there is to this. So took us a while to get it this simple, but that's where we are now. So that's pretty much the whole story on what I've got to tell you. So ask me some questions and we'll see if we can answer them for you. Okay.
We have one question already.
Okay.
About, can you put the adjustable guide rail on both sides of the conveyor?
Yes, we can. Sure.
Absolutely.
Yeah. Let me see the bracket again there, Mike. And again, this is standard spacing in the conveyor industry here. Okay. So you can take off what you've got and you can put this on. You can put it on both sides. So that's how this is set up. Fits on anybody's conveyor, not just ours. Okay. Next question. How do we cure cancer? I don't know.
We have a question, and I'm going to tell you what he said. Can you repeat it? Because apparently the chat is having a
Okay. All right.
It looked like you adjusted the rail in the middle, and the rest of them followed. They followed that setting. Do you have to set each bracket?
Yeah. Let me kind of show you what's happening here. Let me unhook this. I'll show you what's going on here. Okay. When you roll this curve, okay, this is kind of an important thing here. We roll the curve to the center of the adjustment radius. In other words, if it's going to go 0 to 4 inches, we're going to roll this curve at about 2. Okay, so the curve has a little bit of spring to it when it's back, and a little less spring to it when it's forward. And these rails are connected to these transition pieces so that when you just move one, it reaches out and tends to move the other ones, but they're not going to the same spot. So it just, you have to go back and set each one and lock them down. So I think that answers that question, Steve. Is that right? Okay.
Okay, we have a question. Can these be made double high on one side?
Yes.
Can you repeat the question for everybody?
Oh, they want to know if we can have two rails on one side. The answer is yes. Yeah.
And but there's another question. Actually, it's has something to do with our development right now. They have asked. It looks like the product could hang up on the rail at the point where they expand and contract.
Yeah. Okay. Let me show you that. This conveyor is set up for product to go. Okay. They want to know how the transition works as products are going down. We're gonna flow this way. There's a 5 millimeter step right here that's going to occur, right? Where these two lap over, right here, see? As this thing changes radius. And so it flows over, comes onto this rail. This rail is then set on the outside of the next rail. So it sandwiches like this. That's how we put this thing together. And that's how we can get this thing to change radius in the curves. So there is a step there though. Go ahead, Steve.
Okay, that next question is, can you give a range for cost compared to current or conventional approach?
On a component basis, it's about 12% cheaper than the industry standard right now. And this is, by the way, let's get into that. We're marketing this as components that you do it yourself. We're going to send you the parts, help you get started, put them on yourself. So
I think you just answered the next question, which was, can they be used on other manufacturers' conveyors?
absolutely. Goes on anybody's conveyor.
Questions, 'cause they can't-
Oh, I'm sorry. You want to know if this will adapt to anybody's conveyor? And the answer is yes. It's designed to go on anybody's conveyor in the world, really. So again, on the black part, that's standard industry bolt patterns that are on the side of the black piece. So yeah, right here, Seth, there you go. This is the standard bolt pattern that the industry uses now, but it will go on anyone's conveyor though. So
Next question I have is, are they washdown capable?
yes, they are. Oh, I'm sorry. The question is it washdown capable? The answer is yes. These materials are just as resistant to washdown as the chain itself is, pH values and so forth. So it's basically made out of the same material that the chain's made out of, with the exception of the hard anodized guide rail. What you got, Stevie?
Okay, so earlier we had a question about the product hanging on, do you want to tell them about what we're working on right now?
What's that?
The product hanging at the clip.
Oh,
So
yeah,
notice it
yeah,
looks like it can hang.
yeah. There's see the clip right here? The clip has a sharp corner on here. We're going to change that, make it easy, but the face of it actually extends beyond the nose of the clip. You got about a 2 millimeter extension on the crown here of this. Plus, you know, this is the only guide rail we've made so far. We can make many different kinds of guide rails. So we can make a rail, for example, that comes down straight, goes out, has a straight wall on it if that's what people want. So
Okay, we have another question. You'll want to repeat this one. What is the maximum reach when being pushed inward? I guess what's the range of motion?
okay, this setup has a range of motion of 100 millimeters. So you could have 100 on both sides. This is a 300 millimeter chain. So you go from 300 to 100. We have a secondary system has only 50 millimeter throw for smaller bottles. So this 100 millimeter throw, we have 50 millimeter throw as well.